Korb. I am the Public Affairs Director for the American Society for Biochemistry and Molecular Biology, and I would love to take a moment to thank you all for joining us here today for our presentation with the highly respected and greatly appreciated Dr. Shirley Tilghman. Just a couple of quick logistical things. If you have questions throughout this presentation, there is a question and answer window on your screen. You can simply jump in there and type in your question, and I will be playing the part of Donahue at the end, filtering your questions and providing them to Dr. Tilghman, who will answer your questions at the end of the presentation. So thank you very much for that. If you have any issues at all during the conference, you can send me a message through the chat window, or you can email Andre Porter, who is ASBMB's Public Affairs analyst, and he'll be able to help you on the side if you have any technical problems. His email address is aporter, A-P-O-R-T-E-R, at asbmb.org if you have any issues throughout the session. I would like to now hand it over to Natalie Ahn, the president of ASBMB, to make introductions. Natalie, the floor is yours.
Thanks a lot. Thank you, and welcome everyone to this webinar. And on behalf of ASBMB, welcome to Shirley Tilghman, who will present on the future of the biomedical research workforce. Shirley is known to many of us. Dr. Tilghman is a distinguished molecular biologist. She's a member of the National Academy of Sciences, and she's president emerita of Princeton University. And one of her passions for more than 20 years has been to advocate for early career scientists. And she's been one of our nation's strongest voices in addressing the need for reforms to our system of training and employment in order to ensure a stable and sustainable workforce of biomedical researchers. And it's this passion that the ASBMB Public Affairs Advisory Committee recognized in awarding Dr. Tilghman with the 2017 Howard K. Schachman Public Service Award. And today Shirley will tell us about what she's learned, where we are, and directions for the future. And thank you, Shirley, for presenting this webinar on a critically important problem that all of us in research and education need to understand and seriously engage with.
Well, thank you, Natalie. And before I begin, I really would like to thank you, Natalie, to Ben, and the membership of the ASBMB for the honor of receiving the Howard Schachman Public Service Award. It means a great deal to me, and I am very happy to be participating in this webinar on a topic that I've been really focused on for the last 4 years since I stepped down from the presidency of Princeton. Just a bit of a background for everyone on the webinar. As Natalie implied, I've been a member of the biomedical research enterprise really since the 1970s when I was a graduate student. But I think what has really informed my recent advocacy work for young investigators in particular, but the enterprise in general, was taking basically a 12-year sabbatical away from the community. You know, during the 12 years I was the president at Princeton, I just simply could not be paying attention to what was happening in my own community. And so it was when I returned after that 12-year hiatus and began once again spending time with my colleagues here at Princeton, but also colleagues from around the country, that I began to realize how dramatically, at least it felt to me dramatically, things had begun to change and continued to change since I left the field. So a lot of my perspective is in fact informed by having spent a fair amount of time learning how other scientific disciplines organize themselves and organize their workforce, and a sense that things had not gotten better while I was away. They had in fact become considerably worse. So that's a little bit of a background on how I became sort of reactivated on studying these questions involving really the health of our enterprise. So I have called this webinar Rescuing Biomedical Research, a Malthusian Dilemma. And just for point of reference, to remind everyone who Thomas Malthus was, he was an English political economist and was probably the most important person to really begin to think analytically about the critical question of supply and demand. And so you can see on the right-hand side of this slide that Malthus, in this case, was talking about population, but he was desperately concerned about the issue of what happens when basically populations outstrip the resources that are available to support a community. So I think that the way he has defined this problem is very relevant to what I see happening in biomedical research. So let's just go through, first of all, the issue of supply, and I suspect I do not need to tell anybody on this webinar that we have been living through a period of relative austerity in the resources that fund biomedical research that come not entirely, but very significantly from the National Institutes of Health. And what this slide simply shows is what has happened to the total NIH budget over the last 16 years in current dollars, which are the brown bars, and then in constant inflation-adjusted bars, which are really the critical bars. Those are the ones that really matter in the period. There has been only a 14% increase in real NIH funding, and that's less than 1% per year. And you can see it was not even, that there was the very dramatic and certainly at the time welcome doubling of the NIH budget in the late 1900s and early 2000s, but that was almost immediately, in fact it was immediately followed by a decline in the purchasing power to the point that by 2013 we were back where we started in terms of purchase power of the NIH budget. So that's the supply side, which had been growing at an extraordinarily slow rate. But here's the demand side, which is we continue to produce new biomedical scientists at, as you can see, an arithmetic rate that's been quite constant over the last, really, in this case, 35 years, to the point percent increase in the production of new PhDs. And so we now have a mismatch, a disequilibrium between supply and demand. And the consequence of that is a Malthusian dilemma. And another way of saying it, a simpler way, is that there are too many people chasing too few dollars. And the consequence in the lives of scientists, these are, this cartoon, which I took from Science magazine, is meant to represent not just young investigators, but senior investigators, mid-career investigators are feeling the same sense of stress in the system that, and you can see that they are in a juggling act where they are trying to juggle lots and lots of things in this period where too many people are chasing too few dollars. So my co-authors, and I'll talk in a few minutes about who they are, but my co-authors and I, when we began to think about this problem 4 years ago, the word that kept coming back to us is that the culture had become hyper-competitive. And all of us who have practiced science know that science is a competitive business. We do compete with one another for credit for discoveries, but and I actually happen to think that that is healthy. But a hyper-competitive environment is not healthy. And it has led to a number of I think, really deleterious effects that are threatening, I think, the quality of science. Obviously, one of the first is that both researchers as well as grant and paper reviewers have become more risk averse. We hear this over and over again from our colleagues. The second is the amount of time that hypercompetition is eating away from the absolutely critical time that scientists need to really think hard about their experiments. If you are constantly writing and rewriting grants and papers, you are not spending the time you need to spend thinking about your science. So the two questions that we began to ask ourselves are in the red box, which is a hyper-competitive environment conducive to producing the best science? And you can tell from what I have just said, I suspect the answer to that question is no. And the second, will a hyper-competitive culture continue to attract the best and the brightest? And here I feel I'm even on firmer ground in saying no, because I spend a lot of time at Princeton talking to undergraduates trying to decide their career paths. And having seen what it is like to work currently in biomedical research labs, they are uncertain that the playing field is fair enough for them to throw in their lot with the enterprise once they think about graduate school. So these are the two questions that we really began to think hard about. And I want to point out, as I just implied, is that the Malthusian dilemma is particularly acute for the young. So if I think about the 1970s and the 80s when I was coming into the field, the pipeline felt like a very smooth one. One entered the pipeline with some confidence that there was a really interesting career for me at the end, lots of different careers, but there would be a career in which I could take advantage of my scientific training. By 2017, I think it is fair to say that what we have now is a bulging training pipeline. We have a pipeline that is not moving smoothly, and as a consequence, students are spending far more time as both graduate students and postdoctoral fellows. I used to refer to this as they are circling LaGuardia. Those of you who are on the East Coast know what that means if you've ever had to fly through LaGuardia. You are basically circling LaGuardia, waiting for your time to land in a job that is post-training. So there are all kinds of signs of this bulging pipeline, but I'm going to show you two that I think are the most dramatic. On this slide, we're looking at the percentage of NIH R01 principal investigators who are either age 35 and younger, and that's the blue line, or are 66 years of age or older, and that is the red line. And what you can see is that as a percentage of the NIH principal investigator workforce, we have gone from a time in 1980, which is roughly when I was applying for my first NIH grant, where roughly 21% of all NIH recipients were under the age of 35, to the point where we are in this graph that ends in 2014, where it's now under 2%. And you can see that the reciprocal is happening for seasoned investigators over the age of 66. What I think is even more impressive about this slide and worrisome about this slide is, we are talking here in terms of percentages. But look at the absolute numbers, which are in the circles and the boxes. You can see that we have lost 2,000 investigators who are under the age of 35 who are now in their own labs running their own experiments. And this 2,000 person loss is occurring at a time when over a period of time when the biomedical workforce was expanding very significantly in absolute numbers. So this is about as a dramatic illustration of what I think the bulging pipeline looks like as I know. The other, and this is just maybe another way of looking at the same data, although again I think it's a very dramatic way to look at it. These are data that the NIH generated showing that in 1980, the mean age, if you sort of look at the very pale graph here, here I'm going to get my pointer. But the pale lines right here represent sort of the age distribution in 1980 of NIH R01 recipients. And the red line here is, the pale red line is the age of medical school faculty. And there are two things, obviously, to take away from this. One is that if you look at the highest one of those peaks, it's around 37 years old for the grant recipients. The other thing I want you to notice is that this gap between the red line and the blue line all the way along here is about 1 year. And that meant that, by the time you were 1 year into your position as a faculty member at a medical school, you had an NIH grant for the most part. So there was very little of a gap between those two events. So now if we turn over here to 2014, now you can see with the much brighter blue bars that the mean age has now shifted very substantially to the right, someplace between the ages of 50 and 55. And what I think you really can notice here is this gap between the time when you are hired, basically, onto the faculty of a medical school and the time you can expect to receive your NIH grant. And that is now, on average, about 5 years. So it means that there's a period of time for most new faculty in medical schools where they are essentially waiting in order to have the kind of funding that is normally associated with ultimate success as a biomedical scientist. So these are just two ways of seeing how this Malthusian dilemma has really affected, I think, young people in quite dramatic ways. So here's one way that I have thought about how to change the Malthusian laboratory. On the left, you can see what I would call sort of your very typical biomedical research laboratory. You have, and I'm going to get my pointer here again, you have here the leader of the laboratory. You have probably one member of the technical staff, and the vast majority of the people in the laboratory are graduate students and postdocs, and they are performing the vast majority of work in the laboratory. This is Malthusian. This professor down here, this professor is producing vastly more students and fellows than are needed in order to replace him at a time when resources are not growing. This is a classic example of what Malthus was concerned about. It's unsustainable. And so over time, and with care, because we don't want to harm the productivity of biomedical research, we need to get to a more sustainable place where there is still going to be a PI of a laboratory, but more of the people conducting the work in the laboratories are going to be not trainees, not generating new Malthusian dilemmas, but individuals who are working in laboratories and having very productive careers doing so, thus reducing the total number of people that are being produced into the system. So this is where I am hoping we are headed. So one of the things that the group of us, and you can see who the people were who I began having these conversations with 4 years ago, Bruce Alberts from UCSF, Mark Kirshner at Harvard, and Harold Varmus, who at the time was head of the NCI but is now at Cornell Weill. And we met very often for a period of about 9 months and decided that the first and foremost, the most important thing we could do would be to actually write a paper describing the phenomenon that I have just shown you. And so we published this paper in PNAS in 2014, which we laugh is probably the most read paper any of us have ever published, which is sort of depressing, but on the other hand, we're really glad that the paper was read and has been widely discussed. And we're also extremely gratified to see that the issues have now been taken up by many, many additional authors, and I've just put two of them here on the slide. One of them, Ron Daniels, who's the president of Johns Hopkins University, and by the way, remarkably, is a constitutional lawyer, not a biomedical scientist, writing about a generation at risk. And the ASBMB has made a major contribution through a paper here, which is on the bottom here, authored by Chris Pickett, who you will hear about in a minute, Ben Korb, who's on our call, and was the senior author, Jeremy Berg, who at that time was president of ASBMB. And what they did is they went through a whole series of reports, some of which I've been involved with, that have studied this problem in the past, come to very similar recommendations, and basically did a meta-analysis showing the recommendations that were in common. So clearly the community is now thinking and talking about these issues. One of the things that the four of us did together with Judith Kimball at the University of Wisconsin is we formed an advocacy group called Rescuing Biomedical Research, and have raised some money to have an executive director, the same Chris Pickett, who was the first author on the last paper I talked about. And you can see at the bottom that our purpose in forming this organization was really to catalyze the changes that address the systemic flaws in the biomedical research enterprise. And we've been up and running now for almost 2 years. And I'm going to tell you about some of the progress that has been made. We certainly do not take credit for a lot of the progress, but we're working hard to bring it about. The other thing that was really, I think, exciting and gratifying to see is that the postdoctoral fellows themselves, beginning in Boston, but now in several countries cities around the country, organized themselves into an organization called the Future of Research. And you can see what they say here, that they're a group of postdocs invested in improving the scientific endeavor, and their interests are very similar to the interests that RBR has. And in fact, we have 2 members of Future of Research on our steering committee, so we are highly aligned with this wonderful organization. So the rest of the webinar is really going to, I hope, have a positive tone, because what I want to do is talk about some of the things that have happened and are happening with or without the advocacy of RBR and the Future of Research. So I want to talk about, in this slide, on what I consider the lowest of low-lying fruit, something that has been recommended for 20 years and has never been sort of systematically instituted, but is now, I think, on its way to having this happen. And that is to provide truth in advertising to prospective graduate students about each one of the graduate programs that are aiming to train them for careers in biomedical science. There are, I think, 2 sort of issues of progress to report. First of all, John Lorsch, who is the director of the National Institute for General Medical Sciences, last year sent an instruction to all graduate training programs that are funded by NIGMS, basically without sort of a heavy-handed mandate requiring that they post on the web information, both demographic information and career outcome information about their graduate programs that are funded by NIGMS. I'm just showing on the bottom of this slide a truly outstanding example of this kind of transparency. This comes from the Rackham Graduate School at the University of Michigan. If you're interested, you should go on their website. It is stunning the amount of data that they provide, so that any prospective graduate student will have a very clear idea of what's in store for them should they embark upon a graduate career. The same Ron Daniels, the president of Hopkins, is putting together a consortium of universities who are going to commit to doing this kind of transparency for their graduate program. So I feel as though this is something that is going to happen, although it is certainly a long time in coming. The second thing that I think is happening is a recognition among most of the graduate programs that I've visited over the last 2 or 3 years that as the careers that PhD students will ultimately embark upon in the future are to a certain extent different than where they were 20 or 30 years ago, there needs to be recognition of that in the way in which we educate our graduate students. And the slide that I'm showing below just gives you a sense of how dramatic the changes really have been. If you look at the time when I was, sort of applying for my first faculty position, which would have been around 1978, and here I'll find my arrow again, right about here in 1978, I had a 40% chance of 5 to 6 years out of my PhD of being employed in a tenure-track position at a university. That was the majority career, and you can see this here, beginning in 1973, but you can also see what has happened to it over time, that basically it has now become just one of many, many career outcomes. And although this graph ends in 2006, it wouldn't look any different today. Basically, there is no such thing as an alternative career. Basically, all careers of PhDs in the biomedical sciences are alternatives today. So one of the things that has been, I think, really, again, gratifying to see is the degree to which universities are now really embracing this idea that there needs to be diversification in the training. And I give the NIH some real credit for creating these BEST grants, which are broadening experiences in scientific training. There are now 17 of them around the country. And the purpose of these grants is to encourage universities with graduate training programs to think about how to reform their graduate education so that, as you can see down here, that you develop professional skills, individual development plans for students, and ways for students to, in a substantive way, explore different career paths by, in some cases, by experiential learning. I've just taken the website of UMass, which is the site of one of these BEST grants, but there are 16 other ones around the country, and it means that there is serious learning going on about how to think about graduate education when the career outcomes are now so diverse. Here's a recommendation that has, I think, a great virtue, and the person who I most associate with this recommendation is Keith Yamamoto, who is at UCSF, and he has made the case over and over again that too often the postdoctoral period has become sort of a default step. It's what you do after a PhD, irrespective of what it is you think you might like to do ultimately. But as Keith shows here, as people go into law, as they go into education, as they go into communication, business, all kinds of other things, it is not at all clear that doing a 5 to 7 or 8 year postdoc is the best use of your time after receiving a PhD. And he argues, and I agree with him, that the postdoc should really be reserved as an option for those who really are certain that they want to conduct research, whether it's in a biotech firm, whether it's in government, whether it's in academia. But if you, by the time you're finished your PhD, you're fairly certain that you are going to be in one of those other spokes of the wheel, spending time as a postdoctoral fellow does not make sense. And I think we would all agree with that, and we think this would take a lot of people who are currently in that circling LaGuardia position, it would take them out of that position. Here's a recommendation that's been around for about 25 years, which is a recommendation that the best way to support graduate education is through either individual fellowships or training grants rather than simply supporting students on R01s. And if you go all the way back here to the early 1980s, you will see that in fact that graduate students were being supported on a mixture of funding sources, but training grants and fellowships were quite a significant fraction of those. By the time you get to 2009, and it has continued since then, you can see that this is very different. That virtually all of the growth in graduate students' support has occurred on the support of R01s, and this has the impact of graduate students being transformed from trainees to workers. And the reason why that is problematic is because if we are going to diversify the training of graduate students, it is very hard to do this when PIs believe that they are paying the salaries of their graduate students on their R01s. They are being paid to conduct work, and time off to spend time away from the bench, rather, to think about how they want to conduct their future careers is just a very, very hard argument to make to most faculty. So there is a really pragmatic reason to look for a change in the way in which we support graduate students. Keith Yamamoto, and I agree with him again here, has made the very strong argument that our graduate students are not workers, they are students. And the degree to which we have treated them like workers, I think, has added to the problem. Here's probably one of the most difficult, but I think ultimately one of the most important changes that many of us would like to see in the biomedical enterprise. And I referred to it briefly a few minutes ago, and that is to decrease the ratio of trainees to permanent staff in the laboratory. So this is the only plausible solution to the Malthusian dilemma. And here is some progress that has been made toward that. The National Cancer Institute created a grant mechanism called the Research Specialist Award. This was created by Harold Varmus when he was still the director of the NCI. And the purpose of these grants is to encourage the development of stable research career opportunities for exceptional scientists who want to continue to do research but do not want to run a laboratory themselves. So these are grants that are being awarded to individuals who want to work in individual labs, like my little cartoon characters here. But I think just as importantly, these grants are meant to go to individuals who will also run what we are now calling innovation platforms in institutions. So this needs a little bit of explanation. I think everyone who works in biomedical research probably works in an institution that has at least a handful of core facilities. And these core facilities have been often very excellent adjuncts to the conduct of research. Certainly I can tell you, as someone who did mouse genetics, I could not have survived without an animal facility that was professionally run. I benefited from DNA sequencing facilities where I could hand over my samples and get the DNA sequence back in a few days, electron microscopy facilities, and so on. These tended to be, however, facilities that really thought of themselves as service organizations. They were there to serve the individual laboratories to perform work that was more suited to being done in a facility rather than in individual labs. Maybe the best examples are the animal facility and the, say, electron microscopy, where it would be inconceivable that every lab would have an EM facility. What we're beginning to see at institutions like the ones that are mentioned here on the slide, we're beginning to see sort of an evolution of core facilities into what I call innovation platforms. So these are platforms that are run by extremely talented scientists who are being compensated in an equivalent way to faculty, who see their role not just to serve the scientific community, although that is certainly going to be part of their role, but to be really at the cutting edge of the technology that is contained within their innovation platform. The Broad Institute, Janelia Farms, and the Cancer Research Institute in Cambridge have instituted these kinds of innovation platforms, and they are really driving science at those institutions in a very profound way. What it also means is that the need for individual investigators to feel as though they have to be bringing in the cutting edge of technology into their own labs all the time is diminished. It also means that a greater percentage of the actual work that laboratory must conduct to make discoveries is being done on these innovation platforms, which means that fewer people are actually required in the lab to have the same impact, to have the same productivity. And I put Chan Zuckerberg on here because they have indicated in their design of the BioHub at UCSF that they intend to run CZI in the same way, with a much greater emphasis on professional scientists who do not see themselves as contributing to the Malthusian dilemma, but who will have extraordinarily productive and exciting scientific careers pushing the development of technology. So this is happening. I think one of the challenges of having this instituted more broadly is to sort out how individuals in these positions will be treated by their universities, by their departments. It really matters that they have status. And the second is that each one of these institutes on this slide have independent philanthropic funding. So we're going to have to figure out a way how to create these for the many, many universities and research institutes that don't have this kind of philanthropic support. Here is another recommendation that I think is at least, I think, being seriously considered. And it comes out of a report called The Postdoctoral Experience Revisited that was chaired by Greg Petsko, where they quite explicitly say that one of the ways to reduce the number of postdocs in the lab is to properly pay them. Studies that were conducted by this group made it very clear that postdocs are just, disastrously underpaid. And so one of their strongest recommendations is to increase the pay for postdoctoral fellows. As it happens, not long after that report was issued, the Labor Department reinforced a ruling called the Fair Labor Standards Act that raised the amount of money that one needs to pay under which people have to be paid overtime. And I was extremely happy when Francis Collins and Thomas Perez published this May that they support these overtime rules. They're not fighting them, and they believe in fair pay for postdocs. So I think it's a very good sign that it is finally being recognized that postdoctoral fellows were not being paid in a way that reflected their education and their experience. And so I'm going to conclude in just a couple more slides. Here's one that we've been working on very hard recently at RBR, and that is our championing grants that are specifically directed to the early independence for postdoctoral fellows. There have been a number of them. The Burroughs Wellcome had a wonderful program for a while. The NIH has a series of grants, the K99ROO Pathway to Independence, the Early Independence Awards, the New Innovator Awards. These are fine programs. We totally support them. What worries us is how few grants are in each one of these programs. We believe that these are the kinds of programs that will bring young investigators into the program, into being funded, and in ways that will encourage them to be innovative and risk-taking. And a great model for where this has worked brilliantly has been in the European Union. So the European Research Council created a program about 8 years ago, I think it was, where it separated the grants to young investigators and what they call consolidator grants, which are young investigators 6 years or more out, from those that are awarded to more senior investigators. These grants are reviewed separately, they're thought about separately, and as a consequence, 57% of the grants that are awarded by the European Research Council today are being awarded to investigators within 12 years of their PhD. And you can see how dramatically different this slide looks from the slide I showed a while ago, showing what the distribution of R01 grantees are at the moment. So we're very much interested in learning about this program. The success rate of starting investigators being able to transition to consolidator grants is very high. So it's a way to really signal and encourage young investigators to get up and running as quickly as possible. So this is my last slide. You've seen it before. I just want to summarize that as we look at the hypercompetition, as we look at too many people chasing too few dollars, as we look at the Malthusian problem of a professor producing many, many more students and fellows than is needed for a system that's at equilibrium, we have really come to the conclusion that at the heart of these matters, and all of them are very important, but at the heart of the matter is the unsustainable nature of the way in which we have conducted work in biomedical research. And the only solution, or probably at the core solution, has to be thinking about how we conduct that work differently in the future. This is not something that the NIH is going to be able to do on its own, and it is certainly not something that universities are going to be able to do on their own. It's going to take partnerships. But with some of the progress that we've already seen, I'm reasonably confident that in 10 years when somebody looks at the system, it will look as though it is moving far more to the right of this slide than it has been in the past. And so with that, I'm going to conclude, and I am going to turn the question and answer over to Ben.
Great. Thank you very much. That was really a very informed and interesting webinar. There are a couple questions that I have. Let me remind people, there is a Q&A box on your screen where you can type in your question, or you can type it into the chat window, or if you'd like, you can email me directly at bcorb@asbmb.org. That's bcorb@asbmb.org, and we'll get your question forward. The first question that I see here is, do you have a sense on what the steady state pool of researchers that are needed to ensure sustainability are?
Yeah. Natalie, that's a very hard question to answer, simply because it will depend in a critical way on the nature of the resources that are going to be available. And as you know, one of the horrible things that are hanging over the entire enterprise right now is the possibility that there will be draconian cuts in the NIH budget. I know that there are many people who are confident that the Congress will not let that happen. On the other hand, I think all of us are on high alert, worrying that it might happen. But I think your question is a really important one, and I think it could be modeled. People have tried to model it. The NIH system, the NIH workforce study that I co-authored with a group of people, we tried to do the modeling. We didn't get very far. It's a very complicated question.
Shirley, can you hear me?
Yeah.
I was wondering, you know, that your answer suggests that the ideal is to expand until as long as resources are available.
Right.
Rather than sort of uncoupling the question of resource availability from what is needed to sustain science and civilization, let's put it that way. And you know, that's a very different way of looking at things that we don't really perhaps think about.
Well, the way in which economists think about that question is to talk about percentage of GDP. So you know, there are going to be, you know, countries like the United States that should be spending, you know, I would say between 2 and 3% of GDP on research. That is a way to ensure that you will have in the future the same kind of economic vitality that we've enjoyed during the whole of the, you know, second half of the 20th century. So I think that's one way to sort of assess what the total national R&D budget should look like, federal budget should look like. We're well below that now. We didn't used to be below it. We used to be about at that level in the 1960s, early 1970s, but we've been slowly eroding our commitment to R&D ever since.
All right, thank you for the question, Natalie. I'm going to go ahead and just start pulling questions here from the box here. Shirley, how do we deal with the large number of trainees that recently moved from training into the workforce? What sort of policies do you think are necessary to shift the funding curve back to a sustainable position?
So I'm not sure I understand that question. Can you break it down for me?
I think the question is that, so let's agree in principle that the workforce is not quite balanced properly in order to sustain in the future. But there are a large number of mid-career and young investigators who are at the very beginning of the pipeline and have a career ahead of them that they're trying to design.
Yeah.
You know, and I think maybe the NIH with their recently published and then retracted GSI model was one area where they were thinking, what are some policies that might work or that you think might work to bend the curve to get the balance that maybe you see with the European Council distribution?
Yeah. Well, I would absolutely start with the notion that we should not be reviewing young investigators along with senior investigators. The other thing the ERC did that I think was really smart is they actually defined the percentage of the pool that they wanted to be going to young and mid-career investigators. And so that's one way of simply, frankly, saying that if we are not investing in the future of biomedical research, if we are simply disproportionately funding very senior investigators, we will wake up one day and discover there are no young and mid-career investigators for us to support. So I think that was the case with the ERC, where they very deliberately said our highest priority at the moment is to ensure that there is actually going to be a future for research. And by the way, they're doing this in all scientific fields, not just in biomedical research. So I think that's a policy that could change and would begin to have a very significant effect. I think the policies that universities have to really think hard about, I think, are whether they could begin to move toward something like those innovation platforms that occur at other institutions that would take the pressure off individuals thinking that they must have very, very, very large labs in order to simply just get the work done, or to have all of the technologies that are needed to do their work in their own individual labs. The third thing I think that universities can do is to begin to really think about how to create career paths for staff scientists. I think one of the reasons that staff scientists have been so unpopular in the United States is because there is no obvious career path for somebody who says, I have a PhD, I love doing science, I love being in the bench, I love training young people, but I don't want all of the things that go with being a principal investigator. We have problems funding those positions. We have problems in having universities think about how to structure those positions. And if all of those things could happen, I think it would be really beneficial.
So I'm going to ask a question from a little bit of a different space, because you talked about what universities can do. The question here is, from an undergraduate in biochemistry, what should I be doing or not doing? What advice do you have for undergraduates that are just beginning their careers?
Yeah. Well, I can only tell you sort of what I say to my own students at Princeton. That the number one thing I say is that making a commitment to do a PhD and to become a biomedical scientist does require that you really love the work. You love the field. You have what I used to call fire in the belly about being a biomedical scientist. Frankly, today it is too hard to do it if you don't have that kind of, just love of doing science, of wanting to do science. So number one, make sure you really want to do it before you make a commitment to do it. Number two is, as early as you can in your graduate career, begin to think about which of those many spokes on the wheel, on Keith Yamamoto's wheel, you think you might want to aim for. And as soon as you think you know which of those you want to explore, then I would say explore it. And I always I'll tell you a story because I think it's such a powerful story. I had a graduate student about 15 years ago who came into my lab and told me she wanted to work in a small liberal arts college when she was done. So we designed her whole PhD career around that career goal. She taught with me. I mentored her teaching. When she left Princeton, she decided to go and spend a year being if you want, a substitute professor at a small liberal arts college, so that she would get a lot of teaching credentials. She then went ahead and did a postdoc, but in a field very different than mine, not mouse genetics, which you can't do in small liberal arts colleges, but in plants where you can. And by the time she finished her postdoc, she had, multiple job offers from really great small liberal arts colleges. So she had really taken control and command of her future. And I think that's probably the best advice I can give to a prospective student. The last piece of advice, honestly, is choose your mentors well. Mentors in our business have an enormous impact on both the quality of your graduate and your postdoctoral experiences if you do one. And be very, very careful. Don't just base it on who's famous, or don't base it on just what they work on. Make sure this is an individual who's committed to the future of his or her students.
So that's a really great transition. I know there are not only undergraduates that are here on this webinar, but there are also some people that are on, shall we say, the other end of the pipeline. And so one question that came in was, what about the issue of older faculty blocking positions for the advance of younger scientists?
I think this is a really deep problem. And the hands of universities were really tied in the 1990s when the retirement age was made illegal. So there aren't a lot of things that universities can do to move those faculty who are less productive than they used to be, who are not always contributing their full weight to the teaching agenda of the university. And there's no question in my mind this is a really serious problem. Universities have developed retirement incentive plans. Those are legal, and it's legal to be able to have a conversation about them. But it's one of these classic cases where you can lead a horse to water, but you can't make them drink. So I don't deny that one of the most important things that would make such a difference going forward would be if we could persuade some of our more senior colleagues that it is time to, to let the next generation take the reins.
Another question that I see here is, it seems like all of the plans that exist will result in a relatively drastic reduction in the size of the biomedical workforce. Is that inevitable? Are there any plans that will not result in kind of a shrinking of the amount of people doing this science?
So I would agree with that, except for the word drastic. I don't think we are talking about a drastic change. We're talking about a change in the composition of what a laboratory should look like, with more of the members being permanent or semi-permanent and fewer on their way to being trained to be competitors for the next group of jobs. So yes, I think it does mean that it must shrink. At the moment, the enterprise cannot absorb the number of people who are being trained. But I wouldn't say that it's not going to be a drastic decline. And of course, a great deal does depend on where the NIH budget is going. I think that those who know a great deal more about that than I do are not at all confident that it is going to see the kinds of increases that it used to enjoy in the past, though.
What about did changes in the funding distribution, the age of the research or the diversity, have you seen any reflection or a proportional change in the output of the research? As you tweak to younger investigators, do you get more papers published or more clinical trials or more advances?
I haven't seen an analysis of the kind that you just mentioned. I think as you know, John Lorsch at the NIH and Jeremy Berg before him, and now others at the NIH who are sort of taking up the reins of the productivity of extramural research, have data that suggests that increasing the number of grants hits a point of diminishing returns. Where the additional $250,000 grant into a lab that already has $750,000 does not have the same impact as giving that grant to someone who has either 0 or 1 or 2 grants. And those data look pretty compelling to me. So it does suggest that at some point, on average, and here's where you have to really emphasize on average, having labs grow larger and larger and larger does not increase productivity.
Thank you. Another question, and this is an interesting one. We, in the United States, we really view the biomedical research enterprise as and the university system here as the beacon in the world for kind of the U.S. collecting the best and brightest of the next generation of scientists. How do we balance the need for kind of being that beacon and collecting the best minds the world has to offer with an oversupply of trainees and the need to reduce the size of the workforce?
I don't see them as incompatible at all. I think if as the workforce were to shrink, it does not mean that it still wouldn't attract the best and the brightest. In fact, my experience in Princeton says it would have an even greater chance of attracting the best and the brightest. I think when I think back, and I try not to be nostalgic, but when I think back to my early career, the last thing I worried about as a young investigator was whether I would get funded. I basically knew that if I wrote a decent grant, I would get funded. So I could invest virtually all of my energy and all of my time into doing experiments and planning experiments and working with students and fellows. I also knew that if I wrote a good paper, it would get published. It wouldn't have to go through 4 revisions where reviewers asked me, for 10 more experiments, which would make it an even better paper. So I wasn't writing and rewriting papers and grants. And I could really focus on my work. And so I think that rebalancing, bringing into a better equilibrium the system, would actually improve the attractiveness of the career path for those best and brightest, whether they're in this country or whether they're around the world.
What about the MD, PhD trainees in the system? Are we able to take advantage of the combined degrees optimally under the current demands of the environment?
I think I went from being a critic of the MD, PhD program to I'm now an admirer of the program. And not for philosophical reasons, but for really practical reasons. As I see it, MD, PhDs have more options, and in this particular employment climate, having more options is a good thing.
You mentioned earlier, so this is a question that was asked, how as a graduate student do you know if you're exceptional as a researcher?
That's a great question. I'm not sure any of us ever believe we're exceptional, but maybe I'll tell you about how when I went from wondering if I could be a scientist to believing I could be a scientist. And it really happened when I was in graduate school, when I got a result and I immediately sat down and designed the next experiment, and then I took it to my advisor. And my advisor said, absolutely, you're right. That's exactly the next right experiment. So for me, it was being told that not that I could, follow instructions. I knew I could follow instructions, but I knew that wasn't going to make me a scientist. It was when I could design an experiment.
Is there a role for a master's program instead of the PhDs for building a workforce? I think this relates to the staff scientist issue.
Yeah, and I'm really pleased that that question came up because I had that in my slide deck and I took it out just because I was worried about time. I do think that there is a role for master's students. We certainly hear that from industry, that there are roles for master's students. But I think the best master's programs are going to be highly structured, and they are going to be highly coordinated with the labor market. So I think an example that people are often referring to today are individuals who are trained in bioinformatics. We know that there's a tremendous job market out there for people who are really well trained in bioinformatics, and I could easily imagine creating a fabulous master's program that would lead to very, very successful careers with that kind of training. I don't think there is much of a role for kind of a garden variety general master's program that does not have that kind of tight coordination with the labor market.
I'm going to ask a couple more questions if you don't mind. Comparing biomedical research with some of the other science and scientific fields out there, like chemistry and physics, it seems that biomedical research almost has an unrealistic expectation that academia will absorb all of the trainees into it, as opposed to physics and chemistry, which more and more of those trainees are absorbed in industry and other places and not in academia. Is there an unrealistic expectation in this particular field that needs to be addressed?
Unfortunately, I think there is, but I think it's largely now held by more senior people in academia. One of the things that has really struck me going around the country, and when I give talks like this, I often have lunch or a meeting at least with graduate students and postdocs. They no longer have any illusions about academia as the preferred or the only successful route into a career in biomedical science. But what they complain bitterly about is the unwillingness of their advisor to respect a decision other than the decision to aspire to be an academician. So I think this is a generational difference of perspective that is slowly changing, and it's changing as graduate programs like the ones in the BEST consortium are really seeing the benefits that come from creating graduate programs that are more broadly preparing students for the workforce. So I think there is now a bit of a generational divide in how people are thinking about that question.
All right, there are three more questions we're going to clear the decks with. First, regarding your comments on master's programs, are master's programs then essentially pre-professional?
Oh, not at all. I mean, I wouldn't think about them that way. And you know, is a law degree pre-professional? You know, is a medical degree pre-professional? No, I think the best master's programs are going to be programs that are very oriented towards opportunities in the job market. So I see them as not pre-professional, but professional.
Are you aware? Let's say I'm a student and I'm realizing that my career needs to go out of academia and into another position. Do you have advice on where I can go to get some experience or fellowships, or how can I become more suited for the career path that is more likely to be obtainable for me?
Yeah, and I think, unfortunately, that's a hard question to answer simply because I think the answer is going to be quite different depending upon the direction that you want to go. I think that if you want to go into public policy, for example, I think the paths to public policy are going to be very different than if somebody wants to go toward education or towards, say, publishing. So it's a hard question to answer. But our hope is as graduate programs become more and more savvy about how to help students answer that question, there will be people even within the university who can help, direct you along the right path to whichever direction you want to go.
Question regarding funding. Permanent staff members become more expensive with time, so staff scientists would cost more the longer they're on board. And as their cost grows, increases in personnel costs may not be possible with the size of a grant or the retiree of a scientist. Is there thought going into kind of what the financial demands would be for a shifting towards that model that puts more reliance on the staff scientist and changes that might need to happen in funding mechanisms? There's
no question that a staff scientist will cost more than a graduate student or a postdoc, but I think the right way to ask, to think about that is to ask about productivity. And here there are deep divisions of opinion within the scientific community. If you talk to someone at the NIH where there have been these staff positions for for 20 years now, they will tell you that they would not trade their staff scientists for a trainee for all the, the money in China. And because those staff scientists are enormously valuable to them in their research program. On the other hand, you will hear just as adamantly, you will hear people say, oh my God, you're trying to create the German system, where nobody works hard and where everybody goes home at 5 o'clock and where there's no creativity, there's no ambition. And so depending upon which of those scenarios you think comes closer to the truth, you will see the extra cost of a staff scientist is either a completely worth every dime, or it will be really problematic for you. And that's why when I talked about staff scientists, I really emphasized the importance of having these positions be really respected, have status both within the laboratory, but just as importantly, to be honest, within the university or the research institute itself. How you structure this will very much depend upon whether the cost, which will be greater, is going to be worth it or not. As for the funding issue that I think is implied in your question, I think it's scandalous that the $250,000 kind of artificial cap on the R01 grant. I think it's scandalous. It hasn't increased in quite a few years. It is no longer sufficient to really run a laboratory. I ran my laboratory from 1978 to the time when I became a Hughes investigator, which was 88, for 10 years on a single R01. Had no problem running it on a single R01. I mean, that would be inconceivable today, to run the kind of lab that I ran with a single R01. So I think part of the problem that the NIH could really solve is they have to really think more realistically about what it takes to do a research project and to run a research laboratory.
All right, and then this is going to be the last question, and I think it's really trying to take advantage of just the experience that you have. What does a trainee do if they find themselves in an environment where maybe they're not getting the leadership or the mentorship that they're looking for, or they're finding their mentors to not help them get to where they want their career to go? Do you have advice for a trainee in a situation like that?
Yeah, first of all, it's a really unfortunate position to find yourself in, to be sure. And what to do about it will, to a certain extent, depend upon how far along you are in your PhD thesis. If you're early enough, you may really want to consider making a change before things, get worse. If you're far along, probably the best thing to do, if you are in an institution, and I think most now do this, have thesis committees, is to have a conversation with another member of your thesis committee where you outline for that individual the concerns that you have and ask for their advice and maybe for their help in finding a path through the problem so that you can get successfully to the end of your PhD. But it's sadly not uncommon. And it really puts the student in such a difficult position because this is really an apprentice system where a great deal depends on your relationship with your advisor.
Great, good advice. And on that, on behalf of all of the participants here on the webinar, on behalf of ASBMB, I want to thank you, not just for your time today, but for everything that you've done for the community throughout your career and the things you are continuing to do and will continue to do. I think you do thankless work, and so it's a good opportunity for us all to say thank you.
Thank you so much. It's really been a pleasure.